Welcome to the Young Structural Engineers International Design Competition. I'm pleased to be here today to present the Undergraduate Prize. This competition, which is held every 3 years, challenges young engineers from around the world to test their ingenuity, imagination, and inventiveness. This year, the challenge for the young engineers was to design a sustainable habitat for a coastal community in a least developed country, for people who face the prospect of rising sea levels due to climate change. Design considerations would then include housing, work areas, places for the community to assemble, drainage and sanitation, and these are all real challenges faced by governments and NGOs across the world. Over 200 teams registered for the competition, with many outstanding entries coming in. And following a rigorous shortlisting process, the finalists were chosen by a panel of judges incorporating structural engineers as well as experts in disaster relief. I'm pleased to represent the judges and the education committee here at the Institution of Structural Engineers, who are responsible for running the competition. It was such a privilege to be part of the adjudication panel. It was a fascinating insight into the challenges that climate change poses to these communities and how engineers can create attractive solutions that fit both the environment and, of course, the communities in question. So, on behalf of all the judges, it gives me great pleasure to announce that the Undergraduate Prize 2020 is awarded to the team of Tobias and Maria Valderrabano and Samuel Wright. They designed an innovative hexagonal lattice and joint system for a community in rural Bangladesh. Congratulations to you all, and I pass over to the team to tell us more about their design.
Awesome, so thank you very much. I'm Sam, and Tobias and Maria will be speaking shortly. Firstly, we'd like to thank iStructy for putting on this fantastic competition. We had a lot of fun over summer exploring sustainability in different ways to that which we do at university, just because of the nature of the brief. So our modular hexagonal structure is composed of stilted buildings and rafts, and as far as possible, we used only natural vernacular materials. It's not just low carbon because of that, but we hoped to sustain as much high cultural sensitivity as we could as well. We focused on Bangladesh simply because that country has a major threat of rising sea levels. It's obviously a very flat country, coastal country, and very vulnerable. It also had an abundance of bamboo-based architecture, which we found very inspiring, especially as bamboo is seen as a very great emerging sustainable material.
So we developed some initial ideas individually, and after discussing them, we noticed that there were several reoccurring themes. For example, our focus on vernacular design and wanting our settlement to be a platform for the community to thrive, or how our designs were all modular in nature to allow the residents to customize the areas, all while remaining connected. We selected ideas to carry forward, but we always kept in mind some key considerations.
Our key focus points in the design development stage include the aligning of UN Sustainable Development Goals. We wanted to tackle the brief with a humble design revolving around climate change and its impacts by using locally sourced materials to create a renewable and sustainable community. We also envisioned the settlement to recycle its parts, minimizing the emission and maintaining a net zero operation. This was hoped to improve the localized area to develop a self-sufficient economy based on connectivity and better protection against natural disaster resulted from climate change. Our second focus point is developing a community-sensitive design, which we want to create building blocks to strengthen the community, which are important to the respective cultures, especially in the least developed countries, and ultimately to preserve the similar way of life while increasing the quality. The third focus is the vernacular-driven design and thought process, where our research on local and traditional building styles inspired our design approach, and those elements were later incorporated in the final design. Well, developing from the initial ideas and key focus points that were just mentioned, the final product of a modular hexagonal structure is created. The design focuses on modularity and adaptability of the skeletal structure, which reinforces the interconnectedness of the community and contributes to the growing structural strength and stability relative to the growth of the settlement.
So we were very keen to create something that wasn't just a set blueprint, and we wanted to make a building system to allow for cultural adaptation. Of course, there's more than just one community or country that is threatened by rising sea levels. And this hexagonal structure allowed us to create something that can grow indefinitely in different ways. Also, the axes of symmetry on a hexagonal structure mean that it can, once you have one side length, it's very easy to start setting things out and to measure the rest of it all by relative dimensions, which we found was very useful for communities that don't necessarily have like brilliant setting out equipment or amazing training. We wanted to use steel dowels and nylon ties in some of the joints just to make sure that it would be more durable over time. But as much as we could, we opted for local, natural vernacular materials.
Both conceptually and physically, we wanted our settlement to adapt to the changes in nature and climate so that they work together instead of trying to resist the eventual changes that climate change will bring. For this, we used a combination of rafts and stilted structures in our design, and the rafts adapt to the rise in sea levels, while the stilted structures provide the stability. We also decided to make boats the main form of communication to other areas. And while researching, we found a way to grow plants on water using hyacinths that act as a mesh that supports a bamboo grid, and the soil then goes on top of that, and the plants grow on that. And this would become a large part of the livelihood of the community. We also designed to have an ecological sea barrier around our settlement using seagrass and mangroves to attenuate the waves, and it would grow along with the settlement.
So as Tobias mentioned earlier, we wanted to sort of acknowledge the natural components of the materials that they would degrade over time and they would need replenishing. Something that nature is very good at doing itself is replenishing itself over time. So the joint on the right shows the key joint, hexagonal joint in our structure. It can be loosened and it has structural redundancy, which means that one column can be taken out at a time without having to take down the entire structure. Of course, you can't have loads of people stood on the deck while this is done, but it should allow for one column to be taken out at a time, allowing the structure to be replenished over time, because bamboo isn't necessarily going to last very long in an aquatic setting. The other detail that we wanted to highlight was the bridge in the middle. Obviously, having a timber structure is a fire risk even when it's in the sea. So instead of having every single module having a connected walkway and being really closely tessellated, we wanted to provide some joints in the settlement, divisions that could therefore have a bridge that could be taken up and down to allow for compartmentalization of the fire if one did break out.
So we have come up with some sample layouts for the hexagonal structures and rafts, which included a mosque, keeping the Bangladesh culture in mind. The sample mosque layout can be altered to match other religions when the design is adapted to other least developed countries. Our key approach here is to provide a blueprint for the settlement, which the final product is shaped by themselves to accommodate their way of life rather than dictated by our design.
We designed the overall layout of the settlement considering how the multi-purpose rafts should be in the center to maximize the connections to the stilted structures and make them more stable. And they also provide ventilation and sunlight to the inside of the settlement. They also act as courtyards, which are typical of the vernacular architecture in Bangladesh. The community spaces are also in the center of the settlement, like traditional village structures, though we decided to place the communal kitchens on the edges in case of a fire, it would be easier to control.
This is a diagram that shows how we envisaged the settlement perhaps growing over time. Obviously, this would be over the period of maybe 50 years or so. obviously a community could choose how they wanted to expand the settlement, and it would have to depend on the local geography and topography. But we saw this method as a sort of streamlined way. If the protruding wind is often from the south of the image, then of course, well, that's where the waves are being attenuated by the ecological sea barrier, which grows over time. And also there's in some way, a streamlined shape against it. You can see the small cuts where we would compartmentalize the fire also. So thank you very much for listening. It's been a pleasure to share our design with you, and we hope you enjoyed it.
So thank you so much for your presentation and outlining your design to us. It really exhibited a comprehensive approach and a justified solution to a really well-researched problem. As we saw, the quality of your branding and presentation throughout was really excellent, with a hive design providing this comprehensive approach, to what we'd asked for. The judges were really impressed by the level of the cultural and environmental research that your team had undertaken. You successfully produced a unique design that supported your findings about how the community lived. And so many of the design aspects were covered from the brief as well, including investigating water storage, investigating the waste management, and of course your use of sea barriers to protect the settlement from ongoing degradation as well. We really particularly liked the fact that you'd sort of considered fire risks to the area, and you'd included a first aid point within your design as well. You did identify some important issues with the design, which certainly the judge had agreed would sort of need some further investigation. So you were mentioning sort of looking again at bamboo and exactly how you might want to use that. But overall, the judges found the design really interesting, and especially the problem particularly well researched. So well done. So just a couple of questions really. We wondered whether your use of a cofferdam to install the foundations were sort of the safest or the easiest for using in this kind of situation?
Yeah, so the quick answer to that is this is definitely something that we want to develop further if we did take this design further. So the issue that we had was we wanted to have foundations that could be installed with the sea above or below the ground surface, because obviously over time the sea level would rise. Combine that with, we were kind of challenging ourselves with a sort of thought experiment to do this without using concrete, by using sort of the vernacular materials of the area. And that probably in retrospect is we picked something that maybe had better sustainability credentials, but the safety credentials weren't quite as good. In retrospect, we might have used concrete instead, precast foundations that could therefore be pile driven or put in a slightly safer way, perhaps. But yeah, so that's all about the trade-off of sustainability to safety. And in retrospect, yeah, definitely we might have picked something like concrete that was a bit safer, but we were trying to just sort of thought experiment, and we're just trying stuff out really.
No, and I think that's really very valid. But I certainly think, so one of the other questions I had was probably around that same area. And again, you probably just explained the thought process behind it. But again, sort of perhaps if you were sort of to rethink and change some of the aspects of the design, it might include that as well, is where the community would go if there was sort of, obviously you looked at waves coming in, but perhaps not the disaster events that you might see in this kind of community, with some kind of perhaps tsunami or a hurricane or something like that occurring. Sort of what had you envisaged, or what might you envisage if you looked at the design again to allow the community to sort of shelter from that kind of event?
So in our design, we had basically a wind barrier that can be rolled out in the event of like really high winds and that kind of thing. But of course, it's made out of bamboo, and it would be fixed before the cyclone. And so this would act just as a first barrier to allow the residents to go to the community areas. And yeah, if we were to design them again, then I think we'd focus on making the community areas more stable, using more durable materials to ensure the safety.
Yeah, in our research, we also looked into the current sort of disaster management that they have in Bangladesh, but they also use quite a bit of concrete. So we were like, let's try to stay away from that, to have sort of an innovation where the communal buildings that we've made are all in the middle, where when it comes to disaster or a cyclone or a hurricane or those sort of events, the residential block would be sort of the barrier to protect the middle, like communal bits where the people can be able to gather inside. We've also made like considerations when we're designing where we will put more supports in the communal building, but we thought our design with a lot of structural redundancy will be enough for that. But yeah, we definitely can look into a way that during a course of a disaster, they can evacuate safely and just to be away from the sort of the impacts of the disaster as well.
Mm-hmm. Thank you. Yeah, I think that often my understanding I don't work within this field, but my understanding for it is often the structure, some of the structure does actually remain, but obviously there are other elements that are non-structural that get very damaged, and that's very damaging to both the community, if they are in the wake of that, and also to their possessions as well. So it's certainly something, but I see what you mean about sort of combining that area within the center of the settlement to try and get as much protection as possible for that area. Mm-hmm. And so one final question from me is, obviously we've had to analyze this project, or you've been analyzing this project from afar and doing your research presumably online. How do you think that sort of the communities would have buy-in to that kind of living within the hive design?
So something we were super keen about is that we didn't want to make something that we didn't want to assume anything. We wanted to make it so that it would be adaptable, because the last thing that people in Bangladesh need is people who've never been to Bangladesh to tell them how to live. So that was something we really wanted to avoid. But yeah, it's an interesting question. One about how we would have to be creating an economy with the sort of farming rafts we suggest. But we have seen things in Bangladesh. Our research showed a lot of aquatic-based living that's already starting to exist over there. We found examples of schools that are literally boats that go around and pick children up, and they then teach them in these school boats. And just there's lots of research being done into more sustainable boat travel in Bangladesh using solar cells and things like this, which was the reason that we were confident that our design would be close enough to something that the people would be able to adapt to.
Okay. Thank you, guys. That's fantastic, and thank you very much for your submission, your entry. It's given us a lot of inspiration, and I'm sure it will do to young engineers as well. Thank you.
Thank you.
Thank you.